Let me begin. Thank you very much for joining us for the last session of the day, and also from AED Days 2021. This is the last but not the least. This afternoon we have been focusing on showcasing the excellent initiatives and projects and companies that we already have here in Portugal within the aeronautics, space and defense sectors. And so this last workshop will be focused on the aeronautics sectors. And for that, we have invited three speakers, which I will introduce. We have José Marcelino, which is the CEO from Almadesign. Thank you, Rui, for joining yet another workshop. Then we have João Cintra, which is the section head for Homeland Security and Defense at GMV. Thank you, João, for coming. And finally, we have Gustavo Rodrigues, which is the CEO at Stratosphere. So the objective of, thank you very much, the three of you for coming. The objective, and I think we managed, was to have different perspectives of the different type of activities that you can have within the aeronautics sector here in Portugal. And so that we can have a wider perspective of what's happening. So I think we will start then with Rui Marcelino, which will show us his exciting projects and a lot of them that is involved. So Rui, please go ahead.
Okay, thank you, Rui, for the introduction, and hello also to my colleagues at the panel that I know from so many other projects and initiatives. Good afternoon also to the audience, and as Rui was saying, I was invited here to share a little bit of our experience, and it is difficult to talk about what we do without showing some images. That's why I'm going to share my presentation if technology helps me out. Let me see if it works. Is it okay?
Not yet. It was, and then.
Okay, let me do it again. Okay.
Yeah, put it on slideshow.
Yep.
Perfect.
Okay, so going to the topic of this panel that is called Looking at the Future of Aeronautics, I would say that I don't have the crystal ball, so the best thing to do it would be going through what has been Almadesign experience into this Looking at the Future of Aeronautics. And who already present me, I'm CEO of Almadesign. I'm also a lecturer at the Faculty of Architecture, Urbanism and Design at the University of Lisbon, and also Vice President of the AED Cluster. And this also points to something that I think it's important on this presentation, which is the research side, which is what I do at university, and also the importance of networks, which is also something that I do through AED Cluster. But going to the Almadesign experience and projects, let me tell you a little bit about Almadesign. So Almadesign, we are a design studio, as the name says. And what we do at Almadesign is design, of course, and going from the planning stage, research, concept generation, development, product engineering, until prototype and promotion of the things we developed. Products and services, 75% in the mobility area. Integrating automotive, aviation, railway, and nautical. And we also have products and interiors as core areas. In all these areas, we have been working in the last 25 years, and we have about 800 projects in the past. I mean, from aircraft interiors into small objects. So all of them are products, and that's the area that is of interest to us. But I'm not going to bore you with with all the things we have done so far. I'm going to concentrate on transportation, and especially in the aeronautic area. But I think, and I wanted before starting this presentation to give you a short highlight about what we do in other transportation areas, namely on the automotive sector. And because since the beginning of our activity, one of the first projects that we were assigned was also address the area of aeronautics and automotive together. So it's about the mobility system as a whole. And you probably know the airport bus that you see in 70% of the airports around the world. And that airport has been designed by Almadesign with our clients, Caetano, that most of you probably know in the north of Portugal. And we are in the third generation of this bus. This one is the first one. Well, on the coach and bus area, we have developed things like interiors from dashboards to the cabin of the buses, from coaches that are running in England, in Germany, and so many other countries. And also, and this is something that is important for my presentation today, we are now working pretty much on the area of sustainable energy and things like electrical buses and hydrogen buses. Well, since 2009, we were working in things like autonomous vehicles. This is one of the first autonomous vehicles that has been produced, I think, in Portugal. And of course, also the railway area. I'm not going also to go into detail, just to give an example. The interiors and exteriors of the Alpha Pendular train that goes from Lisbon to Porto has been designed by us. And we say from the cabin into the common areas, from the bar to the toilet. Why am I going through all these transportation systems? I'll follow it. So also the nautical area, we have been working recently on solar boats with a company in the south of Portugal that is producing one of the first solar boats ever produced in the world. And we do from initial definition of the product until the final assembling and building and testing in the sea. So why am I talking about all this transportation before aeronautics? Well, aeronautics has been also a very strong area for Almadesign, but to be honest, we only started in this area like 10, 12 years ago. And through a lot of other experience in R&D, we finally ended up working with TAP Portugal, where we defined together with TAP the full fleet interior of TAP Portugal. And when I say full interior, meaning from the seats to the side panels, interior lining, finishing, galleys, toilets, first class, executive class, working with so many suppliers in the world, such as Recaro in Germany, such as Thomson Seats in Ireland, and with TAP Portugal. And the nice thing is that in the end, most of this design was integrated and assembled here in Portugal by TAP Portugal. So we were working with suppliers from all over the world, and the final integration was done here in Portugal, also with Portuguese suppliers. Another important project that I would like to highlight is that the experience that we had with aeronautic projects in the past lead us to work with Aviation, an Israeli company from Israel, that among others is producing the first electric commuter in the world. And Almadesign worked together with the local companies, with Portuguese companies, to design the full cabin interior of this aircraft. In the end, we finish up building up the full mock-up interior together with companies from Marinha Grande, from Alcanena, from the middle of Portugal. And this was integrated and showcased in Le Bourget 2 years ago as, I would say, the star of the show in the most important aeronautic show in the world, I would say. Well, we were very happy in the end because this project ended up to be successfully awarded as the Crystal Cabin Award in 2020. And just to say, the design and the full cockpit integration has been done by Portuguese companies, and we were competing against companies such as Boeing with the 777 cabin interior, or with Virgin Atlantic with the lounge they've produced also for the aeronautic commercial flights. So this is a proof that Portuguese companies and Portuguese design can succeed in the world, competing against the majority of other competitors in the world. And the second and last part of my presentation, it's about networks. I promised I was going to speak about that, so I will not jump. And the thing is, all of this has been possible because Almadesign has been engaged for a long time in fostering our collaboration networks. We are founder and part of the board presently at the AED Cluster, which is organizing this event, but also at the Railway Industry Association of Portugal and so many others. And why is that so important? Because together with these guys, we have managed to create consortia to go after future projects that would interest the industry in the near future. This is something that doesn't come in a daily basis. A company doesn't come to you and say, okay, you have 4 years to think about what's going to be a new product in the future. You have to start doing it in advance. And so just to go shortly about what we have done together with the Portuguese consortium, I will show you just 2 or 3 projects. One was probably the first one, which was an R&D project with Embraer and many Portuguese partners, where we built the concept of the cabin of the future. And we start by the design activity and ended up building the full cabin and presenting it to the world also in 2012 as winner of a Crystal Cabin Award. But not only, we have developed other R&D projects with Embraer, researching for composites, for example, for galleys and interior systems. And also, I would say this is the project of the projects. We have fostered a local ecosystem to work with Embraer for the future aircraft configurations for 2035, addressing topics like composites, like new engines, like aerodynamics, another feature that probably is of interest of all of you. What this has to do with what I presented previously. Well, from this project, we got the hints of what we have done with TAP from what an interior could be. So we were working in advance about what was done later at TAP. And we also achieved configurations of an eVTOL vehicle that led us to the present work that we are doing with the local cluster and with local industry. Finally, aircraft industry is not only aircrafts, it's also about the service that supports the aircraft industry. So we have worked together in European projects with companies like KLM, the Schiphol Airport, the Hamburg Airport, about what would be airports of the future, what would be the seats of the future, and so many other topics. Avionics is also another area in electronics that we have been working on. And finally, the last project I would like to highlight, it's about urban air mobility. This is one of our latest projects. It's called Flexcraft. It's being researched in the last 3 to 4 years, also with Embraer. And we have developed from models of operation until technologies and new emerging technologies. Currently, the Portuguese ecosystem is working on what this area will be in the next years. And so, again, we are building consortia to work on future trends so that the local supply chain can enter these projects in the future. My last slide is about what we consider our future of aeronautics and trends that we foresee at Almadesign from this presentation. So we are expecting seamless mobility experience, and this is about air, land, and sea, not only aircrafts, but how they interact with all the ecosystem. Second, decarbonization and zero emissions, being it electrification or hydrogen. All of this discussion, there's a lot of work to do on those areas. Urban and intra-urban air mobility, which I've already talked about, being it passengers or cargo. Supersonic flights, which it's strange to see when we are thinking about decarbonization, but that's also a trend that is going on presently. Structural health monitoring and IoT, but Gustavo will talk more about this for sure. Advanced material and additive manufacturing, resilient dynamic supply chains, and reshoring. Think about this. The crisis has brought all the companies to rethink who they want to work with on their future projects, such as Portuguese engineers and Portuguese supply chain. Then finally, autonomous flight system and artificial intelligence. That's what we have been working out. So this, in the end, will lead us to new aircrafts and to new models of operation. And what I think it's important, if you think about going into AED area to work, it's to think that the future is not about what you have seen in the past, it's about new configurations, new model of operation, and you have to be prepared to approach these new sectors. Rui, this is pretty much what I could say in a nutshell about Almadesign and the future trends, and I hope this is inspiring for the audience. Thank you so much.
Thank you, Rui. For sure, it will be. I mean, you have left a couple of very important key messages, of course. My objective of inviting this panel was really to show everyone that we have moved on from a build to print approach, from decades ago, and we have climbed up on the value chain ladder and really are at the design and engineering level, which of course is very important because having some champions within the design and engineering, then as you said, we can also bring the rest of the ecosystem to play. So, and I think you're showing that we are doing more than that. I mean, we are even at the R&D, and really with shoulder to shoulder with the big ones, changing ideas, discussing ideas, trying to find new concepts. And so I think it was an excellent presentation to show everyone that what's on the table for in terms of opportunities for all that are considering to get into this aeronautics. So we'll get back to you for sure for some discussion, but just to make sure that everyone has the opportunity to discuss, I would move forward to João Cintra, which I think will also show us some very interesting things, more focused on electronics systems, but also a lot of exciting stuff that the GMV is doing at the moment. So João, please go ahead.
Okay, thank you for the invitation to be here. Good afternoon for everybody. So I don't know if you know GMV, but I will just do a small presentation about it. So GMV is a Spanish group. It started in Madrid with a spin-off from a university in '84, so a long time ago. Then spread all over the world, as you can see here on the map. These red dots are the office that we have in 11 countries, of course, including Portugal. We are the first foreigner office from GMV. And basically we started with the space technology, but it was really fast to move to defense, to IT and transportations. So I'm the section head here in Portugal for defense, Homeland Security and Defense. That includes also the aerospace or aeronautics department. And what I want to show you today, it's what we are doing, why we are doing what we are doing. And basically we have three major lines here in Portugal. We have our own operating system that is made based on the last technologies. It's IMA, the Integrated Modular Avionics. I will explain a little bit better what that means. And based on these operating systems, we are developing with our partners a lot of applications and a lot of R&D for the next generation of applications in the aeronautics. And of course, this cannot be done without standardization, not only by using standardization, but trying to do standardization for the next systems that we are looking now. So this is not as sexy as Rui Marcelino presentation. I think it's more technical sexy, not so visual sexy. So I hope that you will also enjoy. But what I'm bringing here on these slides is just some of the R&D projects that we are doing now, just to have an idea. So the first one, it's based on machine learning. Of course, machine learning now, it's the next big thing everybody is using. It's the silver bullet for everything. But we are trying to use it in the very precise and useful ways. So in this case, this is a very strange image, but basically what we are seeing here, it's an image from a drone that is that lost the connection with the controller and is trying to land in the safe place. So the project is called Safe Term, and what we are doing is using the camera to extract the type of terrain below the drone and find the best way to land, or the best place to land the drone in the safe way. Safe to the human being, so the idea is not to destroy anybody or kill anybody. So this is made by using machine learning and vision algorithms. Another thing that we are using, and once more with machine learning, it's using machine learning to find out if there are hackers between the communication of the control tower and the aircraft. So this is something that it shouldn't be a problem, but in fact, we are having more and more cases where there are interferences from just jokers to real guys that are trying to influence the airplane. So this is becoming a real problem. From another perspective, and more focused on the aeronautics, on the avionics, we have, for example, this project that was made with Embraer. So this is basically the schema of what could be the next plug and play system for airplane. So for a normal computer science, plug and play, it's a trivial thing. But when we are thinking on the airplane, that means that we have, when we change a camera payload to, I don't know, for a tank here a tank, just by changing the payload, we have to reconfigure all the plane to be compliant with this change, and that means we have to do a certification for it. So it means, I don't know, 3-4 years of work just to change something. So of course, this is just R&D. It will take a long time to reach a real project, a flying project, but it's just to show that we are now preparing the future, probably in 20 years. So this is just one of the perspectives that we are working on. The other, it's our operating system. So I just put here these images because it's basically what makes our operating system so different from the others. So it's based on IMA. That means that we have space and time partitioning, and that is that could be very simple idea, but in the aeronautics it's really important. And what this means is that, for example, in the older versions of the airplanes, what we do, it's we have, for each system, we have a computer, a dedicated computer. What this new approach brings, it's since we have time and space partitioning, we can have multiple applications with different characteristics. That's why we have the wolf and the sheep. And we guarantee that they don't eat each other. So they don't share the IO, they don't share the memory, they don't share everything. So that means that we can have several applications working on the same hardware. So that means that we don't need so much hardware, that we can save space, we can save weight on the airplane, and of course we can save also power. So this is more and more important every day that's passing. So based on this, we are now entering on the market where, I don't know, maybe we have 5 or 6 competitors, big competitors with a long history on the operating systems for aeronautics. So we don't have much chance to fight them. So what we are doing is creating an ecosystem, and an ecosystem to where we can offer our operating system mainly for startups, universities, guys that are starting now, creating the next step, the future. And we are betting on urban air mobility because it's here, it's happening. So it's the time for the next step, and we are betting on that area. For the universities, then it's in the further future. So this is our operating system, and finally the standardization. So normally standardization it's related with heavy processes, very boring. So it's not so much. Of course, there's a lot of heavy processes, because it's needed to make sure that, for example, in our operating system, that it's already certified. We had to pass through a lot of paperwork, but it's needed. It's needed for safety. We must guarantee that the plane don't fall. But in this case, what we are doing, it's besides we are using the standards, we are creating the next standards. For example, the integration of drones in the same space of aircrafts. For example, passengers aircrafts. So this is something that we cannot go around. It's something inevitable for the future. And we have to make it work, because, for example, in the picture, we can see the deliveries by drone, and they are sharing the same space with the airplanes. This will be something happening in the future. So it's something that we are doing to integrate and do the standardization. Another thing that we are looking for, it's of course, it's not putting robots controlling the airplanes, but we are not so far from that. But putting the artificial intelligence systems inside of airplane. And since we have such a strict standardization, strict rules to use to create this kind of systems, when we are talking about artificial intelligence, where we put the machine to learn the system, and we really don't understand what is going inside of the algorithm, how it evolves, where it goes, why it does some of the actions, that is unthinkable to put inside of airplane. So these are very different worlds that are coming together, are coming closer and closer, and we must find some ways to do it. So this is basically what I want to present, what we are doing. And well, thank you for your time. Thank you for your attention.
Thank you, João, very much for your presentation. I think it was clear that, I mean, what we do some very interesting stuff. And particularly, I think there's a couple of messages. I mean, you discussed about certification, right? And we have, for the aeronautics, long development cycles, and that because we mostly, as I mentioned earlier this morning, we deal with critical systems. Now, if something fails, the plane comes down. So this is a very demanding industry and really pushes the boundaries in terms of technology and safety, which I think is something very interesting to talk. And the second thing is, you mentioned again urban air mobility. So it was something that Rui also mentioned. So I think it's clear that is something that we are also very much engaged in, looking at the future, looking at new solutions. And I think that also serves as an interesting prospect for the students. So let me pass now to Gustavo, which is going to talk us about MRO, but not only on the opportunities that we know there are, the need for the technical maintenance, aeronautic technical maintenance, but going a little bit step further and putting a lot of technology on it. And please, Gustavo, go forward. You're muted.
Yeah, good afternoon to all. I think I'm the last one to speak on AED Days, so probably I am the last. Okay, Rui will close the session. So a little bit, I will speak a little bit about Stratosphere and what we are, some of the projects that we are being developed from the last years. Also a little bit about the technology that we work with, mainly to bring that technology to applications in operations, and operations normally imply better knowledge about the status of a system, in this case, an aircraft, an helicopter, an UAV. And that information combined with advanced data analysis can provide very useful insights to the maintainer. So to give really very good information to the to the MRO. Another topic that is important to know, although there are a lot of new aircraft, the world fleet is aging, is not becoming younger. That is normal with persons, with people, is also true with the fleets. And to keep the fleet flying normally implies huge efforts in terms of maintenance of the fleet. So technology can come to their help and to improve that objective. And that's the main point where Stratosphere works. So a little bit about us. Oh, sorry. Okay, a little bit about us. So we'll speak today a little bit about us. For someone that doesn't know, our main product, some of the important technologies, how we handle SHM technology, and our view in terms of implementation in aeronautics, and 2 examples of deployment and 1 or 2 examples of R&D. So preparing the next generation of technologies. So we are critical material. We are Stratosphere. We were critical materials until 2019. In 2019, we have transitioned to Stratosphere. So we are a well-established SME. We had some good successes in terms of prizes and appreciation from several entities. So we are working mainly on these applications of critical structures and critical applications of materials. So where is our technology landscape? We try to blend 3 main areas. One we call advanced analytics, everything that is related with the simulation of behavior of systems, material systems, structures, also multiphysics, and everything that is needed to make that work. Also, we work a lot with machine learning and other IE technologies. And one of our key features is the capability to build digital twins. So digital models that are able to represent the physical behavior of a specific system. Okay. We have also good knowledge of electronics and instrumentation. Part of the implementation of our system means that we have to get data from a specific system, and for that we need to have sensors, and we have to have also acquisition systems, and all that implies that. So using auto self-excitation, analyzing the signals at frequency level and time domain, so things that are related with electronics and instrumentation. And on the other area, we have what we call system integration. That is the group of persons that make everything work together and develops the tools that make the connection between the advanced analytics, instrumentation, and also the presentation of the results. Saying that, we have been developed Prodia, which is a system for SHM, for deploying easily or more easily SHM systems. The product is being around for as a stable version for the last 6 years with some success. So we have 3 flavors. One is more focused in aeronautics and aerospace, and the other 2 flavors are more focused, one in energy, in wind turbines, and the other in complex structures that need more flexibility in terms of modeling of their behavior. So we have some key features that are important. We are not very focused on the problem of sensor and sensor technology. We call ourselves sensor agnostics. We provide full integration with the main data acquisition system. So we are full compliant with COTS. And we can use Prodia as a comprehensive platform to do a lot of things, but most important, to do operation load monitoring, damage tolerance analysis, and SHM, so damage diagnosis and prognosis. So the product has also a very powerful IT behind it, can be deployed in IoT platforms, can be deployed in the cloud, or can be deployed in the customer facilities, and can work with several servers and interact with several dispersed geographic assets. So this is one of the things that is also interesting in the system. The system is patented, is an umbrella patent that was awarded to us in 2012, okay, and keeps going, okay. It's prior art of some of the key OEMs in terms of aerospace in the world. Our patent is referenced by them as prior art. So so in a nutshell, we have ProDia Aero, which is very focused in deployment of this type of technologies in terms of UAVs, fixed wing aircrafts, helicopters, can be deployed in any type of platform, is not platform dependent. And also ProDia IS, which is focused on complex structures that can be a pressure reservoir, can be a complex tower, can be something that is related with a complex and a critical behavior of a structure. And of course, as I mentioned earlier, we have ProDia W, which is more focused on the behavior of wind turbines. What are the technologies? So we work strongly with digital twins. For anyone that doesn't know, digital twin tries to blend sensor, data, integration, and analytics into a digital model of something. There are a huge amount of visions about digital twins. Our vision is more physical based. We try to mimic the behavior of physical systems using data that comes from the system operationally, and use that data that normally is scarce to be able to predict other behaviors in the system using digital twin. Other behaviors can be on different points of the system or can be in the different moments in time. So, and can be both at the same time. So we work very deeply in digital twins. We use a lot of machine learning to deal with data. When we are working with fleets or fleets with a lot of components per aircraft that are being monitored, each mission, its flight generates a significant amount of data, and some of that data can be worked to extract specific patterns, and those patterns can be quite useful to maintainers. And machine learning, either supervised or unsupervised, can have very good tools to be able to deal with that. So we don't work specifically in research on the methods, but we can say that we are a very advanced user of this type of technologies, okay? We can use this type of technology to do a lot of things, but in this case, what we are trying to do is we can, from data from flight maneuvers, and use that data, train deep neural networks to be able for that network to be able to pinpoint if a specific aircraft or a specific flight has generated a very harsh maneuver automatically, based only on their specific acceleration profile. So we can analyze in very much detail the flight profile of any aircraft if we have the right data, and we can use neural networks to be able to do it. This is an interesting application. How we do it, we transform the signals in images. When we have that type of image, an aggressive maneuver has a certain type of behavior in terms of images, and less aggressive maneuvers don't have, and soft maneuvers is completely different. And from that, we can use this information to train neural networks to be able to analyze it. So we have a very deep knowledge in terms of signal analysis and things that are related with all this transformation. We are also investing heavily in augmented reality. Probably in the near future, one of the releases of ProDia will have an AR capability for commercial use. The main objective here is to map the results of damage and superimpose that in real time in real aircrafts wherever there are. So if the maintainer can put the goggles on, can see the status of the system or each component, and even can see the behavior of systems that are hiding from the normal sites. So we can see inside using augmented reality. Augmented reality is a technology that is being used in a lot of things. In this case, we are trying to apply this to damage analysis and damage detection, and also other data can be added to the information that is provided by this. Of course, this works on top of the analytics that we are already providing. Okay, without the analytics, the augmented reality doesn't make much sense. It's a way to deliver more efficiently the results. Okay, that's our perspective on this. How we deal with this? So in any type of aircraft, we need sensorized systems, and we need data acquisition and data processing. Normally, we'll try that will not be very strong on board, so we'll try that to be as light as possible. And we can use the same sensor set and data set to do a lot of different things using the same information. So we can work on what we call life extension to analyze how the life of the platform is being consumed. And there are mainly two strategies. One is more on the operational load monitoring to analyze time history, exceedances, and analyze statistics from specific load distributions. Another normally more interesting, more on the fatigue and fracture side, we can estimate the life or in fatigue or in fracture or both mixed per each component in each platform. And we can provide an estimation of damage progression. And from that, we can estimate the useful life of the aircraft. And on the other side, with the same type of sensors and sensorization, we can work into a more advanced analysis. ARM's more focused on rotary wing, on helicopters, which typically is more data-driven, is more system identification, machine learning, and data fusion, and is focused on specific aspects of the helicopters. And the other more generic, we call SHM, which is focused on diagnosis, location, and also severity of the damage, and also prognosis based on that. So, and in the future, we are already working on this. We call EVHM, Integrated Vehicle Health Monitoring System or Management, where we integrate several behaviors of several systems under the same orchestration, let's say. So that can be quite important because in certain cases, small things that we think are small can compromise the mission. You cannot, the best example is normally you cannot roll your car if you have a flat tire, and flat tire is not a very important thing in the car, but if it's not working, you cannot roll. So sometimes small things have big importance. So this is our view. We can do with the same sensor set in a specific platform. We can do several analyses with different complexity and different levels of integration. Anyway, one example, we have been working with the Portuguese Air Force. In this case, is the example of one of the early SHM deployments in the Portuguese helicopter DH-101 program. It was a joint work between us, the Portuguese Air Force, and also Curtiss-Wright, who has provided all the data acquisition systems that are on board the helicopter. Another thing also with Air Force, the TB30 program, where the trainers are being monitored by Prodia in an implementation similar with the one that I explained, more focusing damage tolerance analysis in fatigue life. And the idea here is, of course, these type of aircrafts are trainers, and the pilots that pilot them are in the early stages of piloting. So they normally abuse a little bit with the aircraft. And this is important to maintain the health of the fleet as healthy as possible. another example. An example that is being finalized, a good program with the Pakistani Air Force for the FP7 program. FP7 program is a variation of the MiG-21, is still in operation, made by Chinese engineering, and they are extending the life of these platforms in Pakistan, and Brodia is one of the base technologies that supports the life extension of the FP7 program. Sorry about that, this was done with the Pakistani Air Force and also Zodiac, which is now a Safran company. And some results, interesting results of the future. We are working with Pássaro, which is a very demanding project led by Airbus. And in Pássaro, we have the responsibility of the SHM work package. And in this case, we are working mainly in piezoelectric sensors, not accelerometers, not extensometers, but PZT. And we are analyzing impact detection in some of the cases with PZTs that are spread around. Imagine a plate, and we have a real impact, and the algorithm will run the data that comes from PZT and tries to guess where the impact is. And we have very good results. The sensors are in green. The real impact is this cross in red, and our estimation is this one in yellow. So in general, we have very good results with our algorithms based in PZT, and also in terms of damage localization, which is a little bit different from impact. So in some cases, or most of the cases, you have impacts, but the impacts don't have the energy needed to do damage, really, okay? And this means that the analyses are different and can be done in parallel. First, detect if there is any impact or not, and then after a while, detect if that impact has generated any damage or not, okay? So it can be something related to that. The first two images are more focused on damage impact, in detection of impact. The other two are more focused in damage localization. So damage localization is a more difficult task. With free sensors, we are normally very close to the damage, but sometimes we have, of course, some results that are not so much accurate as we want. So a little bit about the future. Probably cockpits of the future will have this type of technology on board. That's what we expect. So let's see and hope that we can go there. Other things, we are also working in other areas. In this case, we are working with this interesting consortium to be able to monitor the repairs of structures. Imagine that an aircraft has a certain damage, wherever it is. Typically, the maintenance will repair that part of the structure with a certain methodologies that typically are approved from the OEM. What we are trying to do is to include on that repair monitoring. So the repair brings some kind of monitoring of its status, and that can also help them to analyze the status of the repair throughout the time of operation from when the aircraft is repaired. So this is also quite interesting in that regard. So I think I am in the end. Thank you very much for the time. Hopefully it was an interesting talk. And also, since I'm the last one to talk, to congratulate IAD for the organization of AED Days, which was a very interesting and fantastic event. Okay, thank you.
Thank you very much, Gustavo. It was excellent presentation. And myself, I mean, I did work some time ago in a lot with simulation, and for me, it's always amazing how things are progressing and all the new things that we can do at the moment. And I think another thing that is clear is a lot about artificial intelligence, machine learning, augmented reality. So a lot of things going on the digital realm, things that here in Portugal, fortunately, we have a good human capital on, and it's we can see that a lot of companies are exactly using that to make the different products and to try to differentiate things. So I think that's also a key learning from your presentation. Thank you very much. We are almost out of time, but I don't want to leave without giving some questions. I would start with João. I mean, since we are on AED careers, I mean, the questions are more focused on human resources for you. I would like to ask, I mean, what is your perspective in terms of the students? I mean, of course, you need different levels of expertise. You for sure get a lot of students that come from university. How do you think they come prepared? I mean, how do you think, or do you have any advice that you like to give in terms for them to get prepared to what is the real world, or what do you think? Do you have a big gap between what the knowledge that is given in university and the knowledge that you need in the companies, or we have been reducing that gap? What is your perspective on that?
So in some areas, there are still some gaps. For example, in the technologies that we are using, like IMA, we see that it's very difficult to have students with that kind of knowledge. But that, I think it's normal. And what we are doing, it's doing summer internships, some internships for masterships. So that gets the students the opportunity to start earlier before entering in their first job, to have the first experience and a learning path for them. And they can find out if it's interesting for them or not, and choose the career. What we are trying to also to do in these particular cases like IMA, it's to bring the technology to the university. So as I told you before, what we are doing with the ecosystem, it's one of the initiatives. It's not only expecting the university to adapt to our needs, but to expose our needs to the university. So what we are putting, it's some what we call the XSky in the box. So small boxes giving to the university, so they can try, they can play with it, and they can be prepared to this kind of technologies. In regards of the machine learning, that is another big topic now. It's very nice to see that the students are really looking for it, and the universities are preparing them very well, giving the basic stuff for them to evolve. And when they come to at least to GMV, they are already with very good basis for starting working. So it's very good.
Excellent, João. Good to hear that. So Rui, I will come to you. I mean, let me ask you. You have a lot of experience in a lot of different fields. I mean, when you think about aeronautics, what do you think we can say to people that are looking at job opportunities and trying to understand where they fall? What makes it different to go to aeronautics and for these new human resources?
Thank you for the question, Rui. It's hard to say. I started my presentation saying I don't have the crystal ball, and I don't have the crystal ball neither for what would be the jobs for the future. I think none of us has. So I think the most interesting thing is, like I was saying, what we have defined as the typical preparation for aeronautics sector might not be the one that we will be looking for in the next years. But something we could highlight, for instance, is the fact that if you only think about the new projects and the new needs that are coming both on the operations side, meaning from pilots to ground operations, until the part of engineers, if you just think about the engineering and R&D projects that are raising, well, even yesterday, at the PRR calls, I would say that there is more need for people especially from the engineering force, then there are people doing engineering in Portugal. So there will be a lot of work for sure for everyone. But in my opinion, what can be what can differentiate is exactly not to put in your head. I think that this was clear in my presentation, that being graduated in aerospace or something related with aerospace does not need to be specifically to work in the aerospace business. And the aerospace business will be connected with the aeronautic business will be connected with space. Space and aeronautic will be connected with nautical, with road vehicles, with all the ecosystem. So this most likely, like João was showing, and even Gustavo, will all be connected. The thing is, from those who are entering this world, is trying to understand this as a comprehensive world where the knowledge you get from one area can migrate to another. We call that on the design area cross-pollination between areas. And telling you my experience, if you get only people from aeronautic doing aeronautic projects, you will have the same thing as aeronautic guys have been doing the last decades. And the same works for car industry, the same works from nautical industry. So innovation comes from bringing this experience from one area to the area, to the other. Don't be scared if your first job is not exactly an aeronautic, if it's about, let's say, composites applied to nautical products, because you might bring this experience from one area to the other, and that's where innovation comes from. Same people will produce the same results if they are working in the same area. Well, that's my only challenge for today.
Excellent, Rui. Exactly. That's been a message that I've been communicating also. I mean, the universality of all things. And I would finish with Gustavo. I mean, these industries are more and more global, right? The barriers for changing countries, changing companies is getting smaller and smaller. So how do you think that Portugal and Portuguese companies can compete within this very competitive international market?
Well, I think your question is quite hard to answer very well, but let me give some examples that I know. So normally, Portugal was known by its good workforce in terms of execution, in terms of build to print. Now, in the last, I can say, 10 years, it was discovered by big OEMs in the world, big companies that come here and install themselves here and try to take use and advantage of our workforce, of our engineering workforce. That in general is not bad, is good, because one of the things that was lacking when I was a young engineer, probably as José Rui, we didn't have very good references in terms of good engineering companies well spread around the country. There were always very good examples, even in aerospace and other areas. But now, starting with a multinational and breeding that culture can be quite helpful for young engineers. So it's not bad to start from that point. So in general, Portuguese companies, high-tech Portuguese companies, try to fish some talent in these big worlds. We are always trying to do it. That's our game. We never have, and in the company, we never have exactly the right match to the right profile. But we have people with the right attitude and the right brains. And with the time, things become better and better and better. So for young engineers, I also say that we have to start for somewhere, somehow. And the big idea is to move forward the things that we want to do and to move closer. I think when we have a comparison with 20 years ago, now it's better to have very good opportunities in companies with very nice projects, high-end projects. So we don't have to invent them. They are already there, okay? So there are a lot of opportunities for young engineers and young talent. Saying that, in terms of aeronautics and aerospace, everyone is trying to guess which are the next competencies that will be very, very important. Well, I don't have the crystal ball as Rui, but what I can say is things will become more digital. So digital competencies will be very, very important. When I say digital, in our case, is more data analysis, understanding data patterns, comparing that with a very strong knowledge of base physics, okay? For example, we, in the company, we have software engineers, but most of the people have a physical background, comes from engineering or physics, because what we do needs to have a critical comprehension of the physics that is behind each specific analysis. So this is very important to us. And of course, there are very interesting technical careers, I think so. And there are always good opportunities to lead the companies also of the future. So having a very good insight and being quite entrepreneurial can be also very interesting. And I think the ecosystem is better than a few years ago. Some companies will go ahead, others will fail, but this is really the game of that. So, and that needs to be also fostered. It's also very important to be fostered. Okay.
Okay, excellent, Gustavo. I think with that answer, we wrap up the session. I think it served well its purpose. We have been showing throughout the afternoon, either in space, either in defense or aeronautics. I mean, we have been pushing the boundaries here in Portugal. We are at the design level, engineering, manufacturing, and maintenance with more and more technology. So there's a lot of opportunities for everyone to take advantage of. So thank you very much. I mean, we are already out of time. We will have to close this session. I would like to thank again Rui, João, and Gustavo for joining me on the panel. And for sure, we'll continue to discuss all these opportunities within our sector. So thank you very much all for participating.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Okay, and so for us, I will do also the final wrap-up of AED careers. I hope everyone has enjoyed and found it useful in order to understand how to work within the career developments, how to find opportunities, what we have. I mean, the objective was to have a good overview of what's happening. I think we did a good job on that. And again, I would like to thank KSR Consulting. These are our main partner. Without them, that this event could not be possible. And so I hope you enjoy not only today, but also the talks and conference. And I hope you will join us again next year. So thank you very much. And please don't forget that for the following 3 weeks, all the streamings from Talks from Talks and Careers will be available. So if you didn't have time to watch everything live, that's no problem. You can catch it later. You can rewind. You can go forward and still make use of all the information that was given here. So, okay. So thank you very much again, and we'll see you next year. Thank you.